Welcome to Study Loop.
Welcome to question number 23.34 of chapter 23 electric potential. We have a ring of diameter 8 centimeter. So let me put it again. So this is a diameter. So your radius is 4 centimeter. And there is a charge on this ring which is equals to 5 microcoulomb. So 5 micro means 5 into 10 raised to minus 6 coulomb. And we are given that there is a 3 microcoulomb charge ball of having mass 1.5 gram, which is brought from infinity. So this is from, let's say, infinity. This ball is brought from minus infinity, or say, let's say, in plus infinity, from plus infinity to the center of this ring. So the question is, what is the work done by outsider, or the what is the work done to bring this charged particle 3 microcoulomb from infinity to the center of the ring? And another question is it necessary to take the path along the axis of the ring? And the third question says, if the ball is slightly displaced from the center of the ring, what will it do? And what is the maximum speed it will reach? So for the A part, we will use these two formulas, these and this, and this and this. And for the B part, we will use an argument to find out. And for C part, we will use this formula. So let's start with the first part A. So work done by outsider is delta U is a change in potential energy, and change in potential energy is equals to the charge which has been brought from infinity. So this is Q and this is Q here. And the outside, the Q, capital Q, is on the ring. So delta V is a change in potential, which means that the potential at infinity and the potential at center. So potential at infinity is given as 0, and potential due to the ring at the center is 1 by 4 pi epsilon naught Q over R. Q is the total charge and R is the radius. We are given the diameter is 8 centimeter, so radius is 4 centimeter. So we will use these two formula. So delta V is V final minus V initial. V final is the particle where is at the end, and V initial which is at the infinity. So using these values, we put and find out that W is equal to this value. So W, the work done, is equals to Q, which is 3 into 10 raised to minus 6 coulomb, into 9 into 10 raised to power 9, which is 1 by 4 by epsilon value, into Q, which is 5 into 10 raised to minus 6 coulomb, over R. R is your 0.04 meter. So we have used SI units. So remember to convert this in SI units. So using calculator, it's very easy to find out the value. So we have W equals to 3.38 joule. Since the particle both Q and Q are opposite signs, so the Q and Q are opposite, sorry, are the same sign, so they are repelling each other. Repelling each other. So when brought from infinity, the potential is 0. That means no force is acting on this particle Q by capital Q. So we have done some work against the force acting by capital Q on the Q charge. So work done has to be positive. So work done has to be positive because the force is acting this way and we are acting force this way, and we have moved the distance from infinity to towards the center of the this ring. That means the work done by outsider is positive. Similarly, if we were asked to find out the work done by electric force which is minus of delta u, so this would become minus 3.38. So please understand the difference between these two. We are asked to find this one. What is the work done required to bring the charge from q, which is at infinity, and to the center of this ring. So we have positive 3.38 joule value. Now going to the part B. So we have part B as, is it necessary to take a path along the axis of the ring? No, it's not necessary because volt V or potential is is not a path function, or saying or is independent of path. It means that if you are bringing the charge from infinity, doesn't mean to be that you should bring in a straight line, or you can bring in any way you want to bring, or maybe outside and roaming outside. Your final and initial positions matter. It doesn't matter how are you bringing along which axis against which force. We just have capital Q here and at infinity. So these are two positions given. That's it. So the potential is not a path function or is independent of the path. So we don't need to find out that the path which is taken by Q from bringing from plus infinity to this center of the ring should not be the same path. It can be any path, doesn't matter. So that's your answer. So it's not a path function, so it's independent of the path. We are asked also the why. The answer is very easy because the potential is delta V always. So we need just a difference. So we don't care about what the potential at infinity is, if we just know that potential at infinity is 0 and the potential at q is whatever the value we have here. So we just need to find out delta v. We doesn't care if we have potential between them. Let's say there is some q charge here, but this q charge doesn't provide any potential here and at infinity, so we don't care because we just need to find out the potential at this point and this point and take the delta v and then find out the work done. So coming to the part C, if the ball is slightly displaced from the center, so let's make another slide. So we have this ring. Now particle, let me make the good circle again. So now Q is here, so Q is here. So say that the particle is at the center and the particle is moved a little bit, which means that the force will act on this Q. When is at the center of the circle, when is at the center of the circle, so there is no force on Q by capital Q because the force is acting on Q due to all elements cancels down each factor. So force on Q by Q capital Q at center is 0. So there is no movement. But if we move the particle, if we move Q little bit, there will be some F, non-zero value, and the particle, let's say if it moves towards right side, so this is q capital Q and this is Q, so the particle will start moving this way because they are repelling each other, so the particle moves move and move and move and go to the towards the infinity. So the question is, what is the maximum velocity or the kinetic energy? So we have this formula here. So this kinetic energy, so we can find out the velocity using this work done. So whatever the potential energy it has, delta U, will convert into the kinetic energy. Or saying that gain in kinetic energy. So this is 3.38 joule equals to half mass into v square. Mass is given, which we have 1.5 into 10 to the minus 3 kg. So we have v equals to 2 into 3.38 over 1.5 into 10 to the minus 3. So using calculator, you can find out the value of the v here. So it's very easy. So this is equals to 67.1 meter per second. So that's the maximum velocity Q can have. So it's just very easy because the kinetic energy is maximum when the whole potential energy is converted into kinetic energy. So the whole potential energy converted into kinetic energy, that means the V square is the maximum. That means the V is maximum. So V is max when K E is max and delta U converts completely into KE. So that's your answer. I hope you have understood everything. So you can take a look at the slides again. Thank you.